Hello everyone, it's a pleasure to meet you all. My name is Haegul Pyun, and in this session I would like to talk about how to quickly develop static pages. But before I go into that, let me just say a few words about myself. I work as a front-end engineer in Line UIT Web Service Dev 3 team. I am interested in creating open source projects or participating in one. The information you see on the very bottom is my GitHub ID. I am mainly active in the React community. For those of you interested, I look forward to engaging in the discussion with you through GitHub. So before I start, let me ask you this question. The screen you see here is the event screen of an event recently carried out in Line. How long do you think it took to create this page? I asked the same question to some of the engineers I know. Most of them said that it probably took between 3 to 5 days. But actually the engineer who created this event page built, and deployed this page in 1 day. So how was the engineer able to develop a service and launch it in such a short period of time at Line? In this session, I'm going to go over each challenge we had to think through to speed up the development process. Just a quick view of the agenda for this session. First, I'm going to provide some background information necessary to understand the concept introduced in this session. Next, I'm going to go over each individual problem we faced in creating static pages. And last, I'm going to talk about the improvement we achieved while trying to resolve the problems we faced. Before going into the details, because I talk a lot about the concept of web pages in this session, I will briefly go over this concept to facilitate understanding. The web pages you all view a lot nowadays have a lot of content being updated in real time. In case of services with personalization features, many of the times, different pages have to be shown to different users. The news page you see on this slide will display different news according to the time and personal interest of each user. These types of pages are called dynamic pages. Dynamic pages process data and show customized pages to the users, so they require a database and a web application server. When the client side sends a request, the web application server either views the database or retrieves data from an external server and renders the HTML. This concept where the server dynamically generates HTML is called server-side rendering. A dynamic page has a positive feature that it can display dynamic content, but as you can see, it is complex and heavy. And because it shows dynamic data, it is not easy to use cache, so it is not suitable for a service that shows content which does not change frequently. Then what can we do to show static contents that do not change very often? We can use static pages, which is the main topic for this session. This concept, which is also called flat page or stationary page, is easy to understand if you think of the original web pages. Static page is a web page that is delivered to the users in the form that it was saved in. Because it delivers static content, it does not require a separate web application server. Simply put, when client sends a request, the server responds with a saved HTML as it is. The concept might sound primitive, but its advantages come from its simplicity. First, because it does not have a dynamic element, the database is unnecessary, so it is easy to establish. Second, it's composed of simple documents, so there is little communication between the servers, so the transfer speed is very fast. Third, with dynamic pages, it takes some time to see the first meaningful paint, but because the static page sends the HTML right away, so the time taken to see the FMP is very fast. Lastly, with dynamic pages, which handles dynamic data, because the data constantly changes, it is conservative in caching data. On the other hand, because a static page deals with static data, it can cache aggressively. And that is why static pages are widely used in services that quickly display static data. And at Line, static pages are usually used for brand websites, event pages, and so on. As such, static page is used in many different services for various purposes. And with the number of projects increasing, demand for static pages is growing as well. Now, at this point, some of you may be wondering what the problem is. The keyword to describe the problem with a static page is repetition. As I have said before, the demand for static page is increasing. From a large-scale project such as creating a product website to creating simple pages such as event pages or terms of use pages. But the number of engineers and time we have to create these pages are limited. Therefore, we inevitably run into a resource problem. So is there a way to create more pages using fewer engineers? In this chapter, I'm going to talk about the thought process behind solving this problem. In order to clearly distinguish the problem, we looked at the development process of static pages. The structure of a static page is simple, but the development process behind its creation is not so simple. From setting up the development environment to markup for design implementation and additional JS work, if there is a needed interaction, source code is written in the front end like this. Then, is the written source code deployed as is? No, that's not the case. HTML, CSS, and JS go through obfuscation or minification for optimization, and if multilingual processing is needed, we also need to replace the template. This is the work that is done during the build step. Lastly, the engineer is in charge of deploying the build bundle. We would have to set up the web server for deployment and would need TLS support as well, right? And domain would have to be set and would have to come up with a caching strategy suited to the characteristic of the service. I've experienced it in creating numerous static pages as well. If you look closely, many tasks have to be repeated over and over again. But if you think about it, the fact that there is a repetition means that there is a fixed form, and that means that the process can be automated. By systemizing and automating the repetition in the process, wouldn't it be possible to create many static pages using little resource? I will now talk about how we solved the problem of repetition and how we improved. The first thing we have to do is define the problem in one sentence to clarify the problem. And we came up with the sentence, reduce repetitive tasks. So as I have said before, there are many repetitive tasks in developing a static website. So we chose reducing repetitive tasks through automation as our vision, and we came up with the goals for this vision. The first goal is to automate the repeated tasks to save time and effort of the engineers. Second is organizing and standardizing the necessary task based on the reduced number of tasks. If we could standardize the process into a format, we thought that we could reduce time wasted doing the wrong things. Lastly, launching a service requires the cooperation of many different people, including engineers, planners, designers, project managers, and so on, and more communication cost goes into the process than we think. I think reducing unnecessary communication between the relevant departments would quicken the period of service development. Now that the goals have been clearly outlined, we will have to name the project, right? We've gathered many suggestions internally, and we came up with a name with a meaning to make static pages fast. And we decided to call it LandPress. Now let's go back to the diagram that we saw before. We looked for the section we can automate first, and the task that is the most bothersome to do really caught our eyes, which is setting up a development environment, and bundling. We decided to come up with solutions for these tasks first. We thought hard about what platform we're going to use to solve this problem, and because we were doing a POC, we decided to use light and familiar tools. So we decided to try out CLI command line interface. For some of you, it might be the first time you hear the term command line interface. In other words, it refers to a method where the user and the computer interact using a terminal. The structure works in a way that the user inputs the word command in the form of a string on the keyboard, and the output is also given in the form of a string. Its functions can be largely organized into three main functions: transpiling, which changes the ES5 code to ES6 code; obfuscating or unifying, which protects the code; minifying, which reduces the code size; and because we need multilingual support in many cases, we have a function to replace with multiple languages and generate static HTML. Next, it supports simple deployment functions. Making a service, setting up storage, and deploying was quite cumbersome. So as I have said before, by connecting with CDN, we've designed it so that we can deploy to the server with a single command. Lastly, it provides the necessary server for developing in the local environment. It also provides hot module replacement, so changes can be immediately checked while developing. CLI uses Node.js runtime, which is widely used by front-end engineers, so it was developed so that it can be installed using internal private npm. The concept for command words is simple. If you want to create a project, you use the init command to schedule the project, and if you want to run the development server, you can use the dev command to run the development web server applied with hot module replacement. The build process, which was the most cumbersome, only requires the build command for automatic bundling. We designed it so it would work this way. At this point, I'm sure you want to know about the deployment process. Deployment is done through the internal cloud platform called Verda. In Verda, there is an object storage for hosting static files. The bundled files are sent to object storage through the CLI, then hosted. Through CLI, we were able to automate setting up the development environment and bundling processes, but because CLI builds and deploys in a local environment, it can easily be influenced by the user's environment, and it is difficult to manage the deployment history. Most importantly, if we built the production bundle in the local, the biggest problem was that it could be affected by the user's development environment, and there was also limitation in management when the number of projects grew. So we tried to think of a way to improve the development process. And the result was the dashboard. Because CLI runs in the local environment, the limit caused by the environment was clear. So we tried to solve this problem by expanding the platform and implementing it on the web. Also, by building the backend server and database together, we decided to add more functions that could not be provided in the CLI. The page you see here is the new dashboard created by finding solutions to the issues that I've just mentioned. Similar to what we thought of while making the CLI, our design focused on facilitating the development and deployment process. Through the dashboard, the source code can be deployed in 4 easy steps. In the first step, previously, the source code was built in the local environment, but in the dashboard, we designed it so that the source code uploaded in the GitHub Enterprise can be referenced. As you can see, there is a Connect to GitHub button. When you click on this button outlined in red, through OAuth authorization, you can connect to the GitHub Enterprise. In step 2, you can retrieve some of the authorization in GitHub through OAuth authorization. Based on the retrieved authorization, you can choose which repository you're going to deploy to, in which organization, and the GitHub. You can also choose which branch you are going to use to deploy the source code to. In step 3, you enter the project's build information such as the domain, node version used for the build command, environment parameter, cache duration, and so on. When we click on deploy of the created project, source code is retrieved based on the entered build information and it begins to build. Once it is done, it moves on to automatically deploy on the selected CDN. Let's take a closer look at the internal structure. When the deploy button is clicked, the LandPress server sends GitHub information, build command, environment parameter, cache settings, and other build information as a Jenkins cluster. Based on the received information, Jenkins, using Docker, creates image and container is executed. Because each build environment is separated into containers, building without being affected by the environment is possible. Within the established container, building is done, and the completed bundle is sent to Verda object storage. And then it's completed. Taking a step further, we thought about ways to reduce the development time even more. The elements that take a part in the previously mentioned development process are build and deployment. We thought if there is any way to automate build and deployment tasks, and we improved the situation using webhook. The source code worked on in local is pushed to GitHub Enterprise's remote storage. When the push is completed, the webhook in the LandPress backend registered in GitHub is triggered, and once the push is complete, LandPress builds based on the retrieved source code and deploys in the CDN. Other actions beside push can be used according to the webhook event based on various conditions. This is how a continuous integration and continuous delivery concepts were implemented. Now, we have automated the build and deployment processes using LandPress. Lastly, we thought of ways to save the engineers' time in front-end tasks. The requirements for front-end tasks vary, and because of this, there are many different logic as well. At first glance, it seems like these tasks cannot be completed without being manually done by an engineer. But is there any way to reduce the work that goes in? Static pages are usually used to deliver static data to the users. Then that means the delivered data content plays an important role, so we decided to take a closer look at the concept of content. As I have mentioned before, static pages deal with static data, so it doesn't have a separate database. So when the new information is added, it requires a code modification. This means that modifying a simple value or fixing a typo incurs development cost. Then can we make the content area into an abstract and therefore separate it from the source code? This thought naturally pops up. If we separate the content data and send it when a request comes in from the client side, then the process becomes the same as the dynamic page and we lose the strength of the static page like cache. Then how should we separate them? There are many ways, but I would like to introduce the concept of one of them. Have you heard of Jamstack? Jamstack is an abbreviation of JavaScript, API, and markup. As you can tell from the abbreviation, Jamstack refers to a web technology stack composed only of JavaScript, API, and markup. The concept is similar to but different from the concept of dynamic page. Let's take a closer look. Jamstack assigns all of the processing related to the client to JavaScript. Most of the processed contents are dynamic functions. And all of the functions and business logics that can be reused are abstracted into API. Many functions are abstracted to API, but here, let's focus on the content side. When we are creating a static site, all of the necessary data needed to be retrieved from an external environment that has been decoupled. And what is usually used in Jamstack in this situation is Headless CMS. When something is headless, it means that the thing doesn't have a head, and in this case, the head refers to view, which is the measure to show the content. Therefore, Headless CMS refers to a system that eliminates view and focuses on the management of content. To help with your understanding, this is an example of a headless CMS used internally. The image you see here is the framework of Strapi that is used internally, and as seen in the left screen, users can freely configure the data fields used in the content by adding the desired schema. Based on the design schema, GUI is provided as seen on the right to write the content. Through this GUI, the user can write the data or content and can save the structure as is. The screen you see above has been rendered based on the saved data. As you see here, Headless CMS can be used to design the structure of the content, to write the content to fit the design, and to provide it. Then how was this page rendered? There are various ways to create markup. We can write the HTML ourselves or use template engines such as FreeMarker. Jamstack mainly uses static site generator SSG such as Jekyll, Next, or Gatsby. When SSG is used, data can be retrieved during build time and HTML can be rendered. As I have mentioned before, pre-written HTML does not use the server resource of a web application, but rather is cached through CDN and deployed so it can be quickly delivered to the users. This is an overview of the process of creating a static site using Jamstack. When SSG sends a request of necessary content, Headless CMS retrieves the requested contents and builds it. We thought hard about how we can combine the concept of Jamstack and LandPress to create a synergy effect. We focused on SSG and Headless CMS because build function and deployment function have already been built. The problem was that with SSG, a lot of it is provided as CLI, so there are not many problems. But in case of Headless CMS, because we need a server and database, we would have to repeatedly set up these for each service. So we thought about ways to provide Headless CMS for each service. And we found the solution in Docker. Docker locates an application in a software container and allows it to be executed on its own. And through the internal layer, ports can be divided, so it was perfect. We created the custom Headless CMS image needed for the service and ran it as multiple containers on the Docker, and thereby provided an independent CMS environment. We gave the name LandPress content to the resulting product. We made it so that the user can dynamically create a Headless CMS by clicking on the Create Project button. The created CMS connects to the LandPress deployment system to proceed with build deployment. This is how the overall sequence diagram looks like. The user writes contents through Headless CMS. Once the content is written, the Headless CMS triggers the hook for the LandPress trigger. Then the LandPress becomes aware that a new content has been written and patches the source code in the GitHub. And based on the source code data, content data is retrieved from the Headless CMS during build time. Finally, after bundling based on content data, it is deployed to CDN and the process is completed. Now, engineers don't have to edit the source code every time a new content is added. At this point, we felt like we needed to do one more thing. Is there any way to shorten the development period by reusing the source code that was made before? We decided to go a little further. Static site generators provide a template ecosystem so that existing components can be recycled. Inspired by this idea, we tried to think of a way to reuse the existing source codes. Focusing on the fact that the formats of landing pages, event pages, and terms of use pages are standardized, we thought that maybe we could provide a template and CMS as a bundle. We could standardize the widely used patterns and register the templates, and when the user selects a template, based on the selected template, a headless CMS instance with a predefined schema could be generated and content can be written and deployed right away. So we thought of this as a scenario, and we thought of a way to make existing UIs into components. In the headless CMS we are currently using, there is a function to define and add dynamic components. And we are planning to make it so that users can place components and organize the page to suit their taste. I will use this sample as an example of my explanation. The buttons you see in the box outlined red are the components that I have predefined. I made buttons, content, text, image components for this example. Now a user can click on the component they want to add to the page. I've created this sample page by adding the components. The components outlined in orange are the media components, and the ones outlined in blue and green are content components. I've also added button component and content component in a similar manner. You can see the page being rendered in order that the components were added, and the ordering of the created components can also be changed. As such, if we can predefine the various components according to their purposes, a user can create a page to fulfill service requirements. In a similar manner, this event page can also be quickly made by combining the components. I hope that you can now understand how this event page was able to be made so quickly. The graph you see here is a brief overview of the person day that was needed to create the actual Miss Contest event page. About 5 days were needed without the land press, but as you can see on the graph, because most of the process is automated when land press is used, so the required resource decreased by a factor of 5. Beside this event, we were able to quickly create many pages in line by using the tech stack that I have mentioned in this presentation. Previously, many tasks had to be manually handled by engineers, but now, using LandPress, we can automate many of the cumbersome tasks with just a few clicks. Our ultimate goal is to create static sites that meet many different requirements without the involvement of an engineer. There are many more things to improve upon, but if we work on them one by one, we believe that it will be possible one day. Thank you for listening to my presentation.